In this video, let's talk about DFT. Okay, so DFT stands for discrete Fourier transform. So basically, in digital signal processing, we study about DFT because in signal processing, if you want to convert your time domain signal into frequency domain signal, we go for DFT. Okay, like if you have an time domain, if you want to convert your time domain signal into frequency domain, okay, you go for DFT. And again, if you want to convert your frequency domain back into your time domain, we go for inverse discrete Fourier transform. Okay, IDFT. So IDFT stands for inverse discrete Fourier transform. So in IDFT, we convert our frequency domain signal which is in frequency domain back into our time domain. So like so the general notation that we give for a time domain signal for discrete time domain signal x of n. So like maybe if x of n is your discrete time domain signal, okay, and if you take DFT, okay, you get a frequency domain signal, and the notation which will be using the entire series of videos will be x of k. And again, like when you take IDFT this Fourier signal x of k, you'll be getting back your discrete time domain signal which is x of n. So basically, like there are several methods to perform the DFT operations. So throughout the series, we'll be talking about two methods. One is direct method, we'll also talk about matrix method. So throughout the series, we'll be discussing about two methods to perform this DFT and IDFT operations. Okay, so direct method is nothing but using the formula or applying the formula directly to perform the DFT operations. So again, the formula to find the DFT is x of k equal to summation n equal to 0 to n minus 1 x of n e power minus j 2 pi n smaller n n k by n n k by n where k equal to 0 to n minus 1. So a smaller n, this is capital N. Okay, this capital denotes the total number of denotes the length of the sequence. Okay, denotes the length of the input sequence x of n. Okay, so again if you want to calculate the inverse discrete Fourier transform, the formula given endpoint DFT, and if you are asked to find the inverse and if you are asked to find the inverse discrete Fourier transform, the formula is 1 by n summation k is equal to 0 to n minus 1 capital X, okay, x of k e power j 2 pi n k by n, where n equal to 0, 1, 2, etc. up to n minus 1. Okay, the other things, like before we go for the problems, the other things that you should know is you should be familiar with some trigonometric formulas. Okay, so you should be, if you are familiar with some trigonometric formula, that the direct method is very easy to calculate. So before going to the problem next video, let's discuss a few trigonometric formulas that will be helpful for us, okay, to learn better. Okay, so what is e power? Okay, let's discuss some trigonometric formulas now. Okay, what is e power j theta? Okay, you should know what is e power j theta, and you should also know what is e power minus j theta. So e power j theta is, like you all know, cos theta plus I sin theta. Okay, and what is e power minus j theta? We'll write as cos theta minus I sin theta, where you must be knowing that cos theta is the real part and I denotes the imaginary part. The other trigonometric formula like which you should be familiar is, let me just write here so that it will be useful for you. Like what is, okay, 0, let me write in radians, 0 pi by 6, pi by 4, pi by 3, pi by 2, 3 pi by 2, pi, okay, for sine and cos. Okay, sine and cos. So you should know that, you know, sine 0 is 0. This is 1 by 2, 1 by root 2, and sine pi by 3 is root 3 by 2, sine pi by 2 is 1, then 3 pi by 2 is minus 1, and you have 0. Again for cos it is, you know, it's 1, root 3 by 2, 1 by root 2, 1 by 2, and 0. And here you have both 0 and cos space minus 1. So like, you know, so this you must know, like, you know, 0, you know, pi by 6 is 30 degree, and pi by 4 is 45 degree, pi by 3 is 90, I mean 60 degree, and pi by 2 is again 90 or 270, again this is 180. So 0 degree, sine 0 is 0, okay, pi by 6 is 30, which is 1 by 2, and sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1, and 270 is, okay, minus 1, and sine pi is 0. So basically you should also know sine n pi is equal to 0. Like we'll be using, when you apply this direct method, we'll be using the formula sine n pi. So you should know that sine n pi equal to 0, and cos n pi is equal to 1 if n is even, and minus 1 if n is odd. Okay, so if you are familiar with this formula, it's very easy to calculate the DFT using direct method. So let me just summarize it. In this video what you have seen is, okay, just an introduction to DFT, and basically like in DFT we convert our time domain signal into frequency domain, and if you want to convert your frequency domain signal back into time domain, you go for IDFT. We'll be using the notations the small x of n to represent the discrete time domain signal, and x of k to represent the Fourier domain signal. Okay, again this is actually called Fourier transform pulse, and if you take IDFT you will get back your time domain signal. So we have two methods, direct method and matrix method. So we'll be solving both the methods. Direct method we apply the formula directly. So the formula is x of k equal to summation n equal to 0 to n minus 1 x of n e power minus j2 pi smaller n, okay, nk by n, where k equal to 0 to n minus 1. This n denotes the length of the input sequence. And if you want to perform IDFT, okay, if you want to perform IDFT, the formula is 1 by n summation k equal to 0 to n minus x of k e power minus j2 pi nk by n, where n equal to 0 to, okay, n minus 1. Again, then you should be a bit familiar with some trigonometric formulas, like what is e power j theta, what is equal to minus j theta, again, and cos theta, sin theta, and all those few trigonometric formulas which you should be familiar, so that it will be a great help to solve the problem. So next video, let's solve a simple problem to perform DFT. Thanks for watching this video.